What's up guys, this is Massey. Welcome to another video. In this video I want to show you some examples regarding drawing a Lewis structure for different compounds. So we need to follow some steps when we want to draw a Lewis structure. The first one, we need to arrange the symbols of the elements in the compound so that the element with the largest bonding capacity is in a center surrounded by the elements with smaller bonding capacities. So here we have HCl. So in step 1 I need to just put these two HCl. The bonding capacity for Cl is 1 and the bonding capacity for hydrogen is 1 as well, because that's gonna be the Lewis dot structure for these atoms. And Cl, there are 7 valence electrons, so it's gonna be 1, 2, 3, 4, 5, 6, 7. So the bonding capacity as you see here for chlorine is gonna be 1, because that has to get the same electron arrangement as noble gases, which we call it octet rule. So we need to have 8 electrons for them, but there is an exception for hydrogen, which we call it duet rule. Hydrogen, the bonding capacity for this hydrogen is 1, because hydrogen, it belongs to period number 1, and the helium has 2 electrons in the valence shell. So we need one more electron in order to get the same electron configuration as helium. So the bonding capacity for these two is 1. So what we need to do then, step 2, we're gonna count all the valence electrons. Total number of valence electrons is gonna be 1 for hydrogen and 7 for chlorine. That's gonna be 8 electrons in total. So in step 2 we counted all the valence electrons for all the atoms in the molecule. So the total number represents the total number of electrons you can use in your Lewis structure. Now next step, we need to place 2 electrons between the central atom and each of the surrounding atom. So I'm gonna have HCl. I'm gonna put 2 electrons in between. So that's gonna be step number 3. Step number 4. Place lone pairs of electrons around each of the surrounding atoms. So here, because we are dealing with 2 atoms only, there is not really a central or surrounding element, but we need to put the lone pairs of electrons for chlorine. So that's gonna be 1, 2, 1, 2, 1, 2. Then what we need to do, we're gonna find out how many electrons are still available. The total number of available electrons was 8 minus 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 8, 0. So there is no more. There is no more available electron. And after that, what we need to do, we need to check if the central atom have the full octet, and what about the surrounding elements. And the last step is going to be the replace shared electrons with dash. So it's gonna be HCl, and these are the lone pairs. So that's the Lewis structure of HCl. Let's see another example. Next example is draw Lewis structure for H2O. So in this case, we need to identify the central atom, which is usually the element with the highest bonding capacity, or the element that we have it only in one atom. So in this example, oxygen is going to be the central atom. So we place it like that, and we put the surrounding element. And after that, we need to add up the number of valence electrons available in an atom of each of the elements. So I'm gonna write total number of valence electrons. There are one electron here, and 6 electrons here. So it's going to be 2 times 1 plus 6. We have 8 electrons. And here I need to mention that the Lewis structure for hydrogen is like that, and oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. So the bonding capacity of oxygen is 2, as you see here. So now what we can do, we need to place one pair of electrons between each adjacent pair of atoms. So it's going to be place a pair of electrons. Then place pairs of the remaining valence electron as lone pairs on the surrounding atoms. So here the surrounding atoms are hydrogen and hydrogen. And hydrogen must follow duet's rule. So we cannot add more electrons for these atoms. So after that, we need to find out how many electrons are still available. So it's going to be 8 minus 4. It's going to be 4 electrons. It's going to be available number of electrons. So then what else we need to do? So these 4, we need to place it on the central atom. So two and 2, 4. So we place it, and what we need to do, we need to check if the central atom has the full octet or not. As you see here, we have 2, 4, 6, 8. So we have the octet rule. There is no more electron. So it means that the Lewis structure is done. What we need to do, we need to replace share electrons with dash. So it's going to be that's going to be the Lewis structure for H2O. Let's see another example. We need to draw a Lewis structure for CO2, carbon dioxide. So first of all, we need to identify the central atom, as I said, which is usually the element with the highest bonding capacity, or we can say the one that we have only one of them. So here we have carbon, and carbon has 4 valence electrons. On the other hand, oxygen is 6. 1, 2, 3, 4, 5, 6. So the bonding capacity of carbon is 4, and bonding capacity of oxygen is 2, because we have 1 and 2 here, and here we have 4. So carbon in this case is the central atom. So we just put it like that, C, O here, and O here. What is going to be the next step? We need to find out the total number of valence electrons. So we have CO2, C is 4 plus 2 times 6, that's going to be 4 plus 12. We have 16 electrons. So what we need to do, the next step, we need to place one pair of electrons between each adjacent pair of atoms. So 1, 2, 1, 2. And after that, we need to place pairs of remaining valence electrons as lone pairs on the surrounding atoms. So surrounding atoms are oxygen. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now we need to find out the number of available electrons. It's gonna be 16 minus 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2, 16. So 16 minus 16 is gonna be 0. Next step, I need to find out if the central atom has a full octet or no. As you see here, central atom 1, 2, 3, 4. So we need to have 4 more electrons in order to have the full octet for carbon. So in this case, we need to move the lone pair from this oxygen and move this lone pair to this side in order to have the full octet for the central atom. So it's gonna be like that. So now if you see here, for all atoms we have octet rule, and then what we need to do, we need to replace share electrons with dash. So it's going to be C double bond with oxygen, It's going to be like that. So that's the Lewis structure for carbon dioxide. Next example is to draw a Lewis structure for CH4 or methane. So again, I need to write down the elements and write down the bonding capacity. That's the Lewis structure for carbon, and for hydrogen is like that. So the bonding capacity of carbon is 4, and bonding capacity of hydrogen is 1. So Carbon obviously is going to be the central atom, and we have only one atom of that. So I'm gonna write the symbol for central atom and then arrange the symbols of the atoms for the rest of the elements. So I just place it like that. What else we need to do? We need to add up the number of valence electrons available in an atom of each of the elements. So that's gonna be total number of valence electrons it's going to be 4 plus 4 times 1. It's going to be 4 plus 4. That's going to be 8 electrons in total. And then what I can do, I can place one pair of electrons between each adjacent pair of atoms, and every two of these dots represents the bonding electron pair that forms a single covalent bond. So 2 electrons between adjacent elements. And every two of these represents a bonding electron pair that forms a single covalent bond. Now what we can do, we need to place the lone electrons around the surrounding elements. But here, as you see here, the surrounding elements are hydrogen. Hydrogen follows duet rule, so we don't need to put any more electrons for hydrogen. Now what we can do, we need to determine how many electrons are still available. So I'm gonna write number of available electrons are 8 minus 8 is gonna be 0 electrons. So there is no more electron left. So we need to see if we have octet rule for carbon. So we have octet rule for carbon, 2, 2, 2, 2. It's going to be 8, so that is good. And for hydrogen, we have duet rule, 2, and 2 here, 2 here, and 2 here. So we just need to replace shared electrons with dash. So it's going to be like that. So that's the Lewis structure for methane. Next example is draw a Lewis structure for NH3 ammonia. So the first thing I'm gonna do, I'm gonna identify the elements. We have nitrogen and we have hydrogen. Hydrogen, we have 1 valence electron. Nitrogen, we have 5. It's gonna be like that. We have 5 electrons, and the bonding capacity of nitrogen is 3, and the bonding capacity of hydrogen is 1. So the central element is nitrogen, so we just place them and we put the surrounding element like that. Then we add up the number of valence electrons available in an atom. So total number of valence electrons is gonna be 5 for nitrogen, 3 times 1 for hydrogen is gonna be 8 electrons. Then what we need to do, we need to place one pair of electrons between each adjacent pair of atoms, and every two of these dots represents a bonding electron pair that forms a single covalent bond. So it's going to be 1, 2, 3, 4, 5, 6. And then we need to place pair of the remaining valence electrons as lone pairs on the surrounding atoms. And the surrounding atoms are hydrogen. Hydrogen follows duet rule, so we don't put any extra electrons on the hydrogen. So what we need to do, we need to determine how many electrons are still available by subtracting the total number of electrons you have used from the total number of valence electrons. So we have 8 minus 6, we have 2 electrons. So we need to place the remaining electrons on the central atom. So we have this one, and we place the extra 2 on the central atom, and then we check if we have octet rule for nitrogen. 1, 2, 3, 4, 5, 6, 7, 8. Yes, we have octet rule. And for hydrogen we have duet rule. So we just replace share electrons with dash. So it's gonna be like this. That's the Lewis structure for ammonia. Next example is to draw a Lewis structure for H2S, hydrogen sulfide. So again, we need to find out the central atom and surrounding atom by writing the bonding capacity of each. Hydrogen is 1, sulfur is gonna be 6. So 1, 2, 3, 4, 5, 6. So the bonding capacity of sulfur is 2. Bonding capacity of hydrogen is 1. So we place the element like that, and then we find out the total number of valence electrons. We have 6 electrons for sulfur, and 2 times 1 for hydrogen is going to be 8 electrons in total. So we have S, H, and H, and we need to place one pair of electrons between each adjacent pair of atoms, and every 2 of these dots represents a bonding electron pair that forms a single covalent bond. So 1, 2, 1, 2. Then place pairs of the remaining valence electrons as lone pairs on the surrounding atoms, as you see here, to get the octet rule. But we know for hydrogen we follow the duet rule, so it's 2 already, so we don't need to put any more electron on the hydrogen. So let's find out the available number of electrons. How do we find it? By subtracting the number of electrons you have used so far from the total number of valence electrons. So we had 8 minus 4, we have 4 more electrons to use. So we need to place the remaining electrons on the central atom. So 1, 2, 3, 4. Then as you see here, we have octet rule for the sulfur. So we need to replace the shared electrons with dash. So it's going to be like that for H2S. So that's the Lewis structure for H2S. Now, next example, we need to find out draw the Lewis structure for C2H6, which is ethane. So what we need to do, we need to have the elements first. We have carbon and we have hydrogen. Hydrogen will have 1 electron. Carbon has 4 electrons in their valence shell. So the bonding capacity of carbon is 4. Bonding capacity of hydrogen is 1. So then we place the elements. So we have C, C, H, 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 and H in here. And we need to place 1 pair of electrons between each adjacent pair of atoms. Every 2 of these dots represents a bonding electron pair that forms a single covalent bond. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. I forgot to mention that we need to find out the total number of valence electrons, which is going to be 2 times 4 plus 6 times 1. So it's going to be 8 plus 6 is going to be 14. Then we need to find out the available electrons. We have 1, 2, 3, 4, 5, 6. 6 times 2, 12. So 14 minus 12. Actually, it's going to be minus 14 because I forgot to put the 2 dots in here. So 14 minus 14 is going to be 0. So we have no more electron left. And we have the duet rule for the hydrogen. So we don't need to place any more electrons. Actually, we don't have any more electrons. And we have the octet rule for the carbon, 2, 4, 6, 8 for this carbon, 2, 4, 6, 8 for the other carbon. So we have the octet rule for the carbon, so we can place the dash for each shared electron. So we have that's going to be the Lewis structure for ethane. Now let's see the Lewis structure for ethylene. Ethylene, again, based on what we had in the previous example, we have the same elements. The bonding capacity of carbon, I don't write it again, is 4, and for hydrogen is 1. So what is the total number of available electrons? Total number of valence electrons is 2 times 4 plus 4 times 1 is going to be 8 plus 4 equals to 12. So what we can do, we can have C, C, H, 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 and H. We have 4 electrons, 4 hydrogens, and we need to place 1 pair of electrons between each adjacent pair of atoms, and every 2 of these dots represents a bonding electron pair that forms a single covalent bond. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. 1, 2, 3, 4, 5 times 2, 10. So number of available electrons is going to be 12 minus 10. That's going to be 2 electrons. So we still have 2 more electrons. What we need to do, here the hydrogen follows the duet rule, so we don't need to put it there. So these 2 electrons, we need to put it in between these 2 carbon, because that makes the octet rule for these 2 carbon as well. So we had 1, 2, and we have another 1, 2. Like that. As you see here, we have octet rule for carbon, 2, 4, 6, 8, 2, 4, 6, 8 for this carbon. So then we can place dash for each of them. So as you see here, we have double bond between the carbon atoms. Let's see another example. Here we have acetylene. So acetylene, we have again carbon and hydrogen. Total number of valence electrons are 2 times 4 plus 2 times 1. That's going to be 8 plus 2. We have 10 electrons. Then we place the carbons and hydrogen. Then what we can do, we can put the dot in between. So the number of available electrons is going to be 10 minus, we use 6, we have 4 more to use. So these 4 more, we cannot put it on the hydrogen, we need to put it on carbon. So that's going to be like that. And now we use them all, and we have the octet rule for carbon, 2 4 6 8 here, 2 4 6 8 for this one. So we just change them to dash. So that's gonna be the Lewis structure for acetylene. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.